In this lecture, we're going to update the current selection variable based on the navigation input. Let's take a moment to examine the values logged in the console. Currently, I'm playing the game. If I press the A or D keys, a vector gets logged. Looking closely, the first coordinate updates. As a reminder, the order of the coordinates is x and y. Therefore, we can conclude only the x-coordinate gets updated. If I press the A key, the coordinate updates to -1. On the other hand, pressing the D key produces a coordinate of 1. For our navigation, pressing the A key will cause the navigation to move left. If the player presses the D key, the navigation will move right. We can detect the direction by checking the x-coordinates. Let's start writing the code. Open the UI controller component. Scroll to the handle navigate method. Let's replace the debug statement with the current selection variable. We're going to update the variable with the += operator. For the value, we're going to use a ternary operator. Ternary operators are great for writing a shorthand conditional statement. Sometimes, we may not want to write multiple lines of code to write a single conditional statement. C# introduced ternary operators to keep our code short and concise. The format for writing a ternary operator is the following. First, we must write the condition. After the condition, we must add a question mark character. If the condition evaluates to true, we can write the code to execute after this character. But what if the condition evaluates to false? After the first expression, we can write a colon character to write a fallback expression. Not all developers like ternary operators. Sometimes they can be hard to read. If you don't like ternary operators, don't worry. I'll provide an alternative solution after giving them a try. Let's set the current selection variable to the following value, input.x greater than 0. First, we must write the condition. The condition checks if the x-coordinate is greater than 0. If it is, we can assume the player is trying to move right. If that's the case, we should increase the current selection variable. Add the following, $1. This bit of code will increase the variable by 1. But what if they're moving left? We should subtract 1. Add the following last bit of code, :-1. Based on the condition, the current selection variable will move up or down by 1. Now, you may be wondering, why aren't we just using the input.x variable? After all, this variable already holds 1 and -1. The answer has to do with the type of the x variable. If we hover our mouse over the variable, the type has been set to float. However, the current selection variable is an integer. Float values cannot be assigned to integers. For your convenience, I provided two alternative solutions to ternary operators. Firstly, you can typecast the variable into an integer by adding the int type in front of the value. C# will convert the type for you. This solution works, but may produce unreliable results. What if the value is not a whole number? The value will be updated, but the value may be different if Unity decides to change the values produced by key presses. The second solution uses conditional statements. It's more code but easier to read. This is important to understand. Ternary operators are seen as clever code. Sure, they're shorter to write. On the other hand, they can be hard to read. What if you need to revisit your code after a year? Reading your code might be difficult. Most developers prefer readability over clever code, especially if they're beginners, more often than not. Ternary operators are used by experienced developers. However, at the end of the day, it's completely up to you. Either solution works. Before considering our solution complete, there's one more thing I'd like to do. Technically, the player can press either key as many times as they'd like. If they press the A key multiple times, the current selection variable may have a negative value. Indexes for arrays or lists may not be negative. The first item will always have an index of 0, nothing lower. We should clamp the possible values. Set the current selection variable to the following: math f.clamp current selection 0 buttons.count -1. We're using the clamp method to restrict the possible values for this variable. On the lower end, the number may never go below 0. As for the upper end, the index should never exceed the index for the last item in the list. There's a trick for getting the last item. We can use the count variable and subtract 1 from it. This value will always provide us with the last index of the list. We're finished. To test our code, let's log the current selection variable. Next, head over to Unity. Try playing the game. If we press the A or D keys, the variable gets updated. Most importantly, the value never goes outside the range of indexes for our list. That's perfect. In the next lecture, let's update our buttons to reflect the current selection.